Hello everyone, my name is AL-Maidan. I'm going to talk today about photovoltaic system. I'll try my best to manage my time. Let's start with the aim of this report is to provide the knowledge about the photovoltaic cells. Let's start with the question. PV, what does it mean? There are semiconductor devices which convert the light from the sun into DC direct current. The earth gets about 17 times 10 to the power 15 watt, which is 10,000 times in power more than we use in the earth. The first discovery in this area was at 1839 by Alexander. I'm trying to go so fast because I have a design at the end of this presentation. I want to explain it. There are three generations of PV. The first generation, they used single crystalline or polycrystalline cells of silicon. The second generation, they used thin films. The last generation, the third generation is that one. This figure shows the relationship between the cost and the efficiency. The first generation, the efficiency was low and the cost was high. The second generation, both the cost and the efficiency is low when they use thin films. The third generation, the efficiency is high and the cost is cheaper than the first and the second generations. This figure shows the forms of silicon, monocrystalline, polycrystalline, amorphous. Let's move to the next question, how PV cells work. When the light of the sun strikes the PN junction photovoltaic cells, it strikes the N region of the photovoltaics, which is on the top, and some photons arrives to the depletion region in the middle. So the holes in the positive region and the electrons in the negative region will increase. Due to this increase, a potential energy is created. So when we connect any load to the PN junction, the current or the electrons will flow through this load, as we can see here in the photo. Structure of solar panel, it has 6 parts. Let's move to my design. I designed a PV system to my house, which is located in Mula. The weather could be 2 days, cloudy or rainy, as you know, Mula. In the worst cases, the temperature could be minus 10 degrees. Depth discharge of the battery is 80. What elements do I have in my house? I want to light 5 10-watt lamps. I have TV, 32-inch receiver. Both the TV and the receiver will be on for 5 hours. Net modem, which is the 12 watt, it will be on for 24 hours. Laptop, HP laptop charger, 3 hours. It will be on for 3 hours. And the phone charger. The total of watts per hour is 256, and the total of watts per hour for the whole day, it's 1156. I did the calculations here. As I mentioned before, when we collect the watts for all the elements, we get 256, which is less than 1200. This table is like a standard to see which voltage system is suitable for our system. Here, our voltage is 200, our watt is 256, which is less than 1200. The suitable system will be 12 volts. The calculations, okay, we did that before in the table. The average power loss is between 20 and 30%. I'm gonna consider it as 30%. We multiply the total watt in a day by 30%, we get 347 watts power loss. We add it to the total power. Our power in a day is 1503 watt. From this equation, we want to find the ampere in a day. We divide the power that we get by 12 volts. Our system is 12 volt. We get 125 ampere per a day, ampere in a day. How many batteries do we need for our system? As we said, as we found before, the total load is 125 ampere a day. The system is 12 volt. Depth of battery is this. Depth of discharge battery is up to 80%. Actually, we can use the battery for We can use 90% from the battery, but it's not good. It reduces the age of the battery. Also, it's 12 volts, as we know. When it when we use like 90% of the battery, the voltage will increase to 11.68 or 65. As we assume 2 days will be rainy or cloudy in Mura, so we need batteries. The charge for the battery will be enough for 2 days. The temperature in the worst cases is minus 10 degrees. Considering the temperature is important because it affects the storage capacity of the battery, as shows in the curve here. Uh, I, I brought this from the data sheet of the battery, which I'll use in my system. When the temperature is zero, the efficiency or the average capacity will be 65. As we mentioned, as we assumed, the temperature will be minus 10. So the available capacity will be about 60. The usable storage equals total load ampere a day times the days of autonomy or the rainy days. We get 250. We divided it by the depth of discharge battery, which is 80%. We get 313 ampere. For the battery, I suggest we use this kind, which is 12 volt, 135 ampere. This is the data sheet of the battery, 12 volt, we found it. Capacity is 135 ampere per hour. Discharge time is 12 hours, as we can see. From the above curve, at temperature minus 10, the average capacity is about 60%. I mentioned it before. Let's go to the storage capacity. As we found, it's 313 ampere. We divided it by the average capacity from the curve, which is 60, 10, with, at minus 10 degree. We get 521 ampere in a day. That's after considering the temperature and the cloudy days here in Muda. We divided it by the capacity of our batteries, which is 135. We get 3.8. It's about 4 batteries. So we need 4 batteries for our system. The batteries will be considered in parallel because we want 12 volts. We don't want to get like 48 volts. In the worst cases here in Mula, even if the temperature is minus 10 and 2 days are cloudy during the week, these batteries will be able to provide the desired power to the house without any problems. According to the world isolating map, Turkey is here, the seasonal average peak sun hours is in Turkey is 5 hours when the solar panel are charging the batteries when the sun is in the middle of the sky. It's about 5 hours. To know how many solar panels we need, I get this from the datasheet of the solar panel that I will use. The final watt per hour over 5 hours is 1503 over 5. We get 300 watts, so we need 2 solar panel. Each one is 150 watt. 150 watt. Also, we can see here the BMP is 18.1, which is suitable for the 12 voltage systems. To know the solar charge controller from the data sheet, the current in the short circuit is 8.87. We multiply it by 2 because we have 2 solar panel. Also times 1.3, which is 30% for guarantee or safety. We got 23. We got 23 ampere. There is no such 23 ampere in the market, so I'm gonna use 30 ampere at 12 volts. So we get 4 batteries, 2 solar panel, and the charge controller is 30 ampere. The inverter, let's go to the inverter. As we calculated before, the total watt for all appliances is 256, which we add between 25 to 30% for guarantee or bigger size. The inverter size should be 265 times 1.3, which is 30%. We get 323, so we need 400 inverter. At the end, the equipments we need for our system are 4 batteries, 12 volts with capacity 135 ampere, 2 solar panels, each one is 150 watt, 30 ampere charge controller, and 400 inverter. In conclusion, the Earth gets a lot of power from the sun. That's 10,000 times more power than the population in the world use. One day, the world could depend on solar energy in the future. So, what's stopping us from using solar energy or solar power? Wish you all the best.